Hello everyone. Okay, so today we're going to do another AP problem. Okay, this is another AP problem. This is actually not that old. It's from the 2017 exam, question number 3. Okay, this is both the AB and BC exams. Okay, and let's read this is number 3. So let's read our problem. The function f is differentiable on the closed interval -6 to 5 and satisfies f of -2 equals 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. Okay, so they don't give us the graph of f, but instead give us the graph of f prime. Okay, so for part A, they want us to find the values of f of -6 and f of 5. Okay, so they give you f of -2 is 7. So because we have f prime, you can see that f of x equals the integral of f prime of x dx. And if we actually want to find the f of x, we're going to have to define this in terms of a definite integral. Okay, we need to define this in terms of a definite integral. Well, what's lucky is that they give us f of -2 equals 7. So our lower limit should be -2. Okay, and our upper limit should be x of f prime of x dx. Okay, and the reason why I do this is because if you use the first fundamental theorem, you get f of x minus f of -2. And they give you f of -2, so this becomes quite easy. Okay, and we can define f of x as equal to, okay, we can define f of x as equal to f of -2, which is 7, plus the definite integral from -2 to x of f prime of x dx. And now we can just take areas, okay, because the definite integral is defined in terms of areas under the curve. Okay, so f of 5 equals 7 plus -2 to 5 of f prime of x dx. Okay, so what do we get? Okay, what do we get? Now, you have this semicircle. Okay, so this is -2. It's quite convenient. This semicircle is under the x-axis. So it's under the x-axis, so this area will be negative. Okay, so we'll have 7, okay, plus -2 pi plus, well, this triangle is over the x-axis, so we get a positive area of the triangle, which is 1/2 times base, which is 3, times height, which is 2. So that's just plus 3. So we get f of 5 equals 10 minus 2 pi. 10 minus 2 pi. That's f of 5. Now f of -6, I wanted to say for last because it does require some definite integral properties. Okay, so we're taking it from -2 to -6. And that doesn't really help us because we want the greater number to be the upper limit. Okay, and however, this is not true. So you can flip the limits of integration by taking the negative of the integral. If you're not sure what this is, you can just look at the definite integral property video. Okay, so we're subtracting the integral because we inverted the limits. Okay, so now this is an integral we can solve. Okay, so we have 7 minus, well, this area is positive. Okay, so because it's over the x-axis. So we have, this is 2, this is 4. Okay, so we have 1/2 times 2 times 4, and that's just equal to 4. So 7 minus 4, which is equal to 3. So f of -6 is 3. Okay, so let's Okay, let's erase. Let's erase this mess, okay? So while I'm erasing, let's look at part B. Let's look at part B. So part B, on what intervals is f increasing? Justify your answer. Okay, so I'm going to explain why. So I won't technically write the justification, okay, just to save time. However, I will provide a clear explanation, okay, so that you would know what to write, okay? So on what intervals is f increasing? So how would you know if f is increasing or decreasing with respect to derivatives of f, okay? So f is increasing if f prime of x is greater than 0 on the interval, okay? So if the slope is positive, then you know for sure it's increasing, okay? Slope is positive, then you know for sure that it's increasing, okay? So we just need to see where f prime of x is greater than 0, okay? So let's not do that. I'm just gonna highlight our graph. So where is f prime greater than 0? Those are the intervals where f prime is above our x-axis. And now you could see it's a bit easier. Okay, it's easier to see. So f prime is positive on the intervals -6. Okay, it's less than x, less than 2. And 2 is less than x, is less than 5. So everywhere on those intervals, you have f is increasing, okay? F is increasing. So you write an interval notation, -6, 2, and 2 to 5. Okay, I think it's this symbol. Okay. So for all x's that satisfy these intervals, okay, that are in these intervals, f will be increasing. So let's look at part C. So part C, find the absolute minimum value of f on the closed interval, -6 to 5. Justify your answer. No, the absolute minimum value of f. So how would you find out what the absolute minimum is? Okay? How would you find out where the absolute minimum is? Well, the absolute minimum value could either be at one of these endpoints over here, or it could be at a critical point, okay? It could be on a critical point. So what are some critical points? Okay, that is when f prime of x, part C, f prime of x is equal to 0. So we can have x equals -2 and x equals 2. Okay? X equals -2 and x equals 2. Now, x equals -2. What do we get? Okay? Well, x equals -2 is, if we find f of -2, that's equal to 7. Okay, just from the information. f of 2 is, well, 7 plus the definite integral from -2 to 2 of f prime of x dx. Okay? And that is just the area of the semicircle. Okay? And you have to subtract this area since it's below the x-axis. So f7 minus 2 pi. Okay? f of 5, we found in part A, is 10 minus 2 pi. Okay? And f of -6 is 3. So let's see if we can order these. So 7 minus 2 pi, Okay, 2 pi is about 6.28, because pi is about 3.14. So f of 2 is definitely the smallest. Next is f of negative 6. After that is f of negative 2. And finally, you have f of 5. Okay, f of 5. So our absolute minimum will be at x equals 2. Okay, at x equals 2, which will be 7 minus 2 pi. It's the smallest value of f on our interval. Okay. For part D, for each of f prime of negative 5 and f prime of 3, find the value or explain why it does not exist. So for f prime of negative 5, so how can we find f prime of x? Well, f prime of x is just equal to the derivative of f prime of x. Okay? So the derivative of f prime of x, we literally need to solve for the slope of f prime at x equals negative 5. Okay? That's over here. So the slope of this line segment. Okay? So we're going down 2 and right 4. So just finding the slope of the line, get f prime of negative 5 is negative 1/2. Now what about f prime of 3? Now this one is strange because there is no slope at this point. Okay, and in fact f prime of 3 does not exist because f prime is not differentiable at that point. Okay, so it's not, turn the eraser. Okay, not differentiable at that point. Okay, so negative 1/2 and does not exist as our answers for part D. Okay, because it hits a spike, okay, and just goes down like a little sharp turn. There is no derivative at that point. The derivative does not exist. So f prime of 3 does not exist as well. Okay, and we're done. We just solved that FRQ. We basically just looked at the derivatives, okay, and looked at how they interacted with each other, and we used that to solve this FRQ. Thanks for watching. If you have any questions, please comment below. Make sure you like, subscribe, all that other stuff. Thanks for watching, and stay tuned for the next video.